What's going on YouTube? It's the Middle School Math Man here. This video is going to be on systems of inequalities, as you can see by the title. So a system of inequalities is two or more linear inequalities. It's just a system. System is two or more. So the solution to a system of inequalities is the overlapping region. It's the overlapping region of points that satisfies both inequalities. So let's take a look at some problems. So if we look at number 1, the very first thing we need to make sure is that they are in slope-intercept form, because we're going to graph them. So if I'm looking at the first equation, x plus y is greater than -1, well, I need to get that into slope-intercept form. So I'm going to subtract x on both sides. So that is my first equation in slope-intercept form. I'm going to do my other equation in blue. So I'm going to subtract x on both sides, so -y is greater than -x plus 5. Now I'm not done yet. I don't want -y. I just want y. So I'm going to divide everything by -1. Now when you do that, anytime you multiply or divide by a negative number, you need to flip the sign. So I flip the sign there. -1x divided by -1 is just positive 1x. 5 divided by -1 is -5. So there is my second inequality. So I'm going to go ahead and graph my first inequality. Y is greater than -x minus 1. And again, I'm going to try my best to do it on here. It's a little bit challenging. So we got all these points. You don't have to do this many. If you have a ruler, you can go ahead and connect them. So there's a couple things to keep in mind. Y is greater than -x minus 1. So there is no line underneath. It's not greater than or equal to. So we need to make sure we're going to have a dashed line. So there's the first inequality graphed. Now I suggest graphing one and then shading it, and then graphing the other and shading it. For me personally, it just gets a little bit confusing when I have two lines on there and then I have to figure out which one is which. So I'm going to go ahead and figure out which side to shade. So I have y is greater than -x minus 1. So we're going to use a test point. So I'm going to use 0, 0, and I'm going to see, is 0, 0 a solution? So if I plug in 0 for y, I'm going to plug in 0 for x. So -0 is just 0. So I'm going to have 0 is greater than -1. 0 is in fact greater than -1. So because 0 is greater than -1, that means 0, 0 is a solution. So I'm going to shade everything above that line where the solution is or was. So that means that every single point above that line is a solution to that inequality. So the other one, I'm going to graph in blue. So -5. And here I have a positive 1 slope. So again, I'm going to have a dashed line here. So I need to figure out which side to shade. So I'm going to do 0, 0 again. So 0 is less than 0 minus 5, which simplifies as 0 is less than -5. So 0 is less than -5. That is not true. 0 is not less than -5. So I'm going to shade below the line because 0, 0 is not a solution. So I'm not going to shade on the left side of that line because then you'd be telling me that 0, 0 is a solution, but we just figured out it wasn't. So the overlapping region on this graph is where it is blue and red. So if you just have a pencil, that region on the graph should be darker than the rest of the regions. So you just need to make sure that you color in that region a little bit darker than the rest of your graph. So that is the answer, or those are the answers to that system. So I could ask you, is 7 -2 a solution? And you could look at the graph and say, oh, well, it's in that overlapping region, so that would be a solution to that system. If you plugged in 7 for x and whatever I said, -1 for x and y in those equations, or excuse me, inequalities, they would make both inequalities true. So let's take a look at number 2. This one should be a little more quick because we only have to convert 1. So if I look at the first equation and I'm converting it, I'm going to add x to both sides. And then I'm just going to divide everything by 3. So I'm going to get y is less than x over 3 is 1x over 3, or 1 over 3x plus 7. So there's my first inequality. I'm going to graph it. And again, this is going to have a dashed line. I'm going to do my best here. So when I plug in a test point, I'm going to use 0, 0 again. So 0 is less than, 1/3 times 0 is just 0, so 0 is less than 7. That is true. So 0, 0 is a solution. So you're going to shade everything below that line. Any point below that line is a solution to that linear inequality. The second equation was already in slope-intercept for us, so when we graph it, let's see what we get. Now this is the first one where it is greater than or equal to. There's a line underneath, and that means we are going to have a solid line. Again, that line is not perfect by any means. It's a little bit hard to write with a stylus, but it should look somewhat like that line. Now, if I have the second equation, I'm just going to do it down beneath. So 0, 0. So I'm going to get 0 is greater than or equal to. -0 is just 0. So 0 is greater than or equal to 4. So you got to think to yourself, is 0 greater than or equal to 4? No, it is not greater than or equal to 4. So I'm going to shade above that line where 0, 0 is not. So your overlapping region is where we have the blue and the red in my case. So it's going to be this region here. So on your paper, when you just have a pencil, you just need to make sure that that region is darker than the rest of the shades. Let's do one more problem. First of all, we need to convert the first equation, or excuse me, not equation, inequality. So y is greater than -10x over 8 is going to reduce to -5 over 4x plus 3. So if I go ahead and graph that, -5 over 4, so I'm going to rise 5 and run to the left 4 if I go up. So 1, 2, 3, 4, 5, 1, 2, 3, 4. There's no line underneath, so it's going to be a dashed line. So when I plug in 0, 0, I'm going to get 0 is greater than 3. 0 is not greater than 3, so 0, 0 is not a solution, so I'm going to shade above that line. So y is less than or equal to 2. Y is less than or equal to 2 is one of those special cases we talked about with linear equations. Y is less than or equal to 2. That line is going to be going through 2 on the y-axis. So It's going through that point, and it is going to be a horizontal line because it's going through that point on the y-axis, and it's going to be a solid line because it's less than or equal to 2. We're still going to do the same thing with the test point. When we plug in 0 for y, we're going to get 0 is less than or equal to 2. That is true. So 0, 0 is a solution. So I'm going to shade everything below that line in blue. So your overlapping region is going to be this triangle over here. So a couple things to keep in mind. Just remember that they need to be in slope-intercept. Then I suggest graphing one, then shading it, graphing the other, and then shading it. And then you just got to keep in mind if it is a less than or greater than problem, so no line underneath, that is a dashed line. If it is less than or equal to or greater than or equal to with the line underneath, it is a solid line. And that overlapping region is where the solutions are.